Okay, guys, so the last time, I think toward the end of the lesson, we were dealing with functions. I think everyone was tired at that point, so I'll do a bit of a recap before we go on. Okay, so guys, I will warn you that the section does get a bit confusing. So try to be with me as much as you can. Okay, so we talk about functions, and to start off, there are three very important things you need to know. These three at the bottom here. Well, there's four actually, but three of them are very important. The first one, the first definition is the image of a function. Right, so it's best defined with an example. So let me give you guys an example. So an image is just an output of a function, right? So for example, if we have a function, something like f of x is equal to 2x, right? It can be any example, any function. Then for the input, let's say the input here is 1, then the output will be f of 1 is equal to 2 times 1, which is 2. This part here, the 2, that's called the image. It's said to be the image of 1. Because you filter 1 into the function and 2 becomes the output. So let's look at another example. Let's suppose I say x is equal to 2. Then f of 2 will give us 4. So in this case, 4 is the image of 2. So your output is always called the image of the input. Okay, is that okay with you guys? Image. Right. So that's the word image. The other three things we will learn are domain, codomain, and range. And I'm assuming many of you heard of domain and range before. Yes. Codomain, I'm not sure if they do that in high school. No. Okay, that's fine. So we learned something new here. So first, I'll define them in words. It might be a bit abstract, and then I'll give you guys examples. So the domain is the set of all inputs of the function. The domain is the set of all the inputs of the function. The codomain is the set of all allowed outputs of the function. And the range are the actual outputs. It's a very subtle difference between codomain and range, right? But we'll see that with an example. Again, if you didn't get the definition, it's okay. It's a bit abstract. Let's look at examples to make it clearer. Okay, so firstly, you'll always be given functions in this form right here. So you guys need to memorize this form and what it means, because this is always the standard. You will be given a function. You'll probably be given what the function is as well. Here we're not, but this is just the standard form. The function f, which is some function, this first part here with the x, that represents the domain. And the second part here with the y is the codomain. So x and y here are just placeholders to represent some set, which is the domain and the codomain. Right? It could be the natural numbers, the real numbers, whatever. All right. Every example will give you what x and what y is. Okay, so again, a bit abstract. Where is an example? There's an example right here. I think we kind of covered this the last time, but again, yeah. Do it again. Guys, when you come in, please close the door, especially when we are recording. Yeah, I do say that every lecture, and somehow people still keep leaving the door open. But anyway. All right, so anyway, as I was saying, I'll just look at this example right here, and we see, let me just bring this up a little bit so we can see, just keep this in your minds. This is the standard form that we always look at. And look at the example, we see it's in the same form, f double dot, some set to some set. And as I said, this first set here always represents the domain. The second set always represents the codomain. So I'm just trying to emphasize this for you guys so that sometimes they'll ask you what's the domain and codomain, and people struggle and try and work it out. You don't have to work anything out. You just read it straight from here. Right. So in this case, if I asked you guys what the domain is, can anyone have a guess at what you think it is for this example up here? Yeah, that's correct, right? It's n, which is the natural numbers. So that's exactly it. The domain is just the natural numbers. Okay, let me write it a bit higher up like this. The natural numbers. Right? And we need to get used to thinking of these as sets now, because the domain, codomain, and range are always sets. So at natural numbers, we will write 1, 2, 3, and so on, just to show you it's a set. Okay, and can you guys tell me what the codomain is here? Yeah. Also, right? Also the natural numbers. So here it's the same thing. It's the natural numbers. Okay, and again, the set looks exactly the same. 1, 2, 3, 4, so on. Okay, now here we'll see the difference between codomain and range. The range here is given by filtering all of these elements of the domain into the function and getting an output. Right? So you plug 1 into the function, you'll get some output. That's the first element of the range. Then you plug 2 into the function, get an output. That's the second element of the range, and so on. So let's work out a few of them. I'll do them here on the side. The first element of the range is given by 1 plugged into the function, which gives us 1 squared plus 3, which is 4. That's our first element. Second element comes from plugging the second element of our domain into the function, which is 2. So you plug 2 into the function. F of 2 is equal to 2 squared plus 3, which is 4, 5, 6, 7. Okay, I'll do just one more. So we got a few going. Third one, which is here, also that into the function. You get f of 3 is equal to 3 squared plus 3 is 9, 10, 11, 12. And so obviously this is going to be an infinite set, just like the natural numbers are. So we can continue doing this forever, but we don't have to. We just do a few, and we can then say the range is 4, 7, 12, dot, dot, dot. It continues forever. Okay, so I wanted this to be the first example because this example makes very clear the difference between domain, codomain, range, especially codomain and range, which sometimes seem a bit too similar. Okay, any questions before we try some examples? All good. All right, so let's try a few here. Find the domain, codomain, and range for the following. Let's just start with number 1 and see how we feel about that. Okay, we'll do this together. So number 1, can anybody tell me what is the domain for number 1? Integers. Perfect, right? It's the integers. So you can just write the set of integers. What I will do here is just list a few out. Say dot, 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 -2, -1, 0, 1, 2, and so on. All the negative, all the positive, including 0. Okay, that's the domain. Can you guys tell me what the codomain is here? Integers, so same thing in this case. All right, so I'll just write the same set here, -2, -1, 0, 1, 2. And I've asked you to work out the range. It will just be filtering the inputs, which are given by the domain, into the function here. Just filter each element into the function and you will get answers. Right, so I think we can write that in one go. If I confuse anybody, just let me know. So range, I'll write it like this, dot, dot, dot. First, we filter -2 into the function. So f of -2 is 3 times -2, which is -6. Then we filter -1. Next one, filter -1 into that. We get 3 times -1, which is -3. And so on. Filter 0, I will get 0. Filter 1, I will get 6. Sorry, not 6, 3. Filter 2, I will get 6, and so on. Okay, so just in case I'm losing anybody here, I'll write that on the side. So starting by f of -2, that's the first element, gives me 3 times -2, which is -6. That's how I worked out the first one. Again, I'm just filtering all of these one by one into the function above, which is given above, right? That's this one up here. Okay. And the -1 gives me 3 times -1, which is -3. 0 just gives me 3 times 0, which is 0, and so on. So that's how I get elements of the range. Yeah, I'll give you guys a few minutes to take that in before we do number 2 and 3, because I need to erase all of this to make space. But taking it down, take it down, take a picture, whatever you need to do. All right, so let's try number 2. Let's make space for that. Okay, for number 2, can anybody tell me what the domain is? 1, 2, 3, right? It's the set 1, 2, 3. So I guess you guys are getting the hang of it now. And the codomain? Perfect. Now this example here is a bit strange because we're not given a function where we have to work out the range. It's as if they filtered it already for us and didn't give us the explicit function. So we don't know what it is. Maybe it's some kind of discontinuous function, whatever, it doesn't matter, right? What they're telling us in this first part here, G1 is equal to C, is if you filter the element from the domain, the first one, into the function G, your output is C. So C is an element of our range. That is one of the outputs. And the next part tells us if we filter 2 into the function, we end up getting A as an output. So the outputs are the range. So we put that here. And the third one tells us if we filter the last element of the domain into the function, we end up getting A. So we put A here again. But now remember, in set theory, order doesn't matter and repeats don't matter. So we don't have to write A 2 times. And if we want, we can even just write A before C to make it alphabetical, because order doesn't matter. So that and that are completely the same in set theory. Okay, number 3 is very similar, except here they show you that there's many ways to represent a function. Here they represent it by a diagram, which is a bit strange, but it still gives us the same information that we need. Okay, so first, let me not get ahead of myself. Let's first get the domain, codomain, and range. So domain, can you guys see what it is here? Anybody? 1, 2, 3. Okay. So you guys are getting that. That's perfect. Codomain, the same thing, right? 1, 2, 3. Now the range here is just the output of this function represented by the diagram. So what's the diagram telling us? It's telling us that if you filter 1 from the domain into the function, you end up getting 2 as an output. So 2 is our first output, right? And if you filter 2 into the function, you end up getting 1 as an output. So 1 is the next output. And 3 just filters and becomes itself. So the last output is 3. But again, we can rewrite this in order because order doesn't matter here. So domain, codomain, and range are all the same thing here. Okay. And sometimes they may ask you to rewrite this. Well, actually, no, they probably won't. But if they ask you to rewrite this as a function, the way we saw it above, since they call this one h, you'll just write something like h of 1 is 2, h of 2 is 1, h of 3 is 3. Just telling you what input goes to what output. If you prefer it that way. Okay, so that's the basics. Everyone still okay so far? Yeah.
Explain the range of things.
The range, sure, no problem.
Because there is 2, 1, and 3.
Yeah. 2, 1. So all I did here is I checked where each input goes. So the input 1, according to the diagram, goes to 2. 2 is the output. And that's why I said 2 is my first output. The second input 2 goes to 1, according to this function. That's why I said the second part of the range is 1. The last one just goes itself. Yeah. So I just made it look, I just put it in order. Yeah. All right, so let's see what happens next. Everyone okay with this so far? Perfect. After that, I'm not sure why they show this, but for some reason they just want to show us what a graph would look like if we were to graph number 3. Let's just look at that for a second. It's so far away. You know what, it's too far away. Let's just make a new graph. So if they ask you to graph this thing, and it's important to label your axis, which they didn't do here. If you were to graph your input to output, or let's say domain to range. If you were to do that, then let's just make 3 values on each axis because these things only go to 3. 1, 2, 3. So again, if you graph something like this, 1 gets mapped to 2 according to the function. Or we can just look here, it's easier. If you just look at what we wrote here on the side, this thing here, we know that 1 in the domain gets mapped to 2 in the range. So we'll find a point here, which is 1 in the domain, 2 in the range. 2 in the domain gets mapped to 1 in the range, so that's somewhere here. And 3 gets mapped to 3, so that's here. So I'm just finding corresponding points. Not sure, they always show this every year, but it never comes out. But must never say never. It's good to just look at it in case it does. Okay. All right, so that's the function. And here's some notation that they sometimes use. Instead of giving you directly a function with domain and range, they may give you the strange notation, which both of these represent the same thing. The line on the top gives you elements of the domain, so all the input, and the line at the bottom gives you all the output, the range, right? There's no codomain shown here. Okay, so it's a bit of a strange one, but also because I don't like the second one because it looks like a matrix, even though it's not technically a matrix, it's input output. You can't really apply matrix multiplication and algebra to this thing like you would a matrix. So I don't like it. Let me just be clear about that. But the IIE wants me to teach it to you guys. So there it is. Okay. All right. We have another example. Let's see. It's now 10:43. Do you guys need another break before this example? Okay, it's a democracy, guys. So let's see. A show of hands if you want a break. Anybody needs a break, put your hands up. Or is that just the extent to which people are not listening to me? You guys are good. If you don't want a break, put your hands up. Yeah, but we still have more to do after this anyway. Do that. Okay, we can do that. Well, this is an example, so it might take about another 15 minutes or so. That's yeah. You want to break before a 15-minute example?
The next break would be go home.
10:45 is usually. You guys want me to continue and then just finish early?
Yeah.
You guys all happy with that?
Yeah.
Okay, let's do that then. All right. Finish early. Even I like the sound of that. All right. So which of the following diagrams represents a function? So for that, we have to go back to the definition of function. Does anyone remember what that was? I think I do, but I'm not 100% sure. I think it gives to each input exactly one output. Yeah, so that's what a function should be. Okay, but let's just make sure since it's on video, we can check it as well. Here's the thing, a function is a rule that assigns each input exactly one output. Right, so we're looking for things that have exactly one output, no more than one output. If it has more than one output, it's not a function. Okay. So let's see if we can use that information to figure out whether these are functions, and they give it in this weird diagram format. So we have to kind of spin our heads around and understand what these mean. Okay, so they're telling us what X and Y is in this case. And remember, this format always tells you domain, codomain. So we're given domain, we're given codomain. Now can we work out whether these are functions? Let's look at number. They're not really numbered. Let's number them. This is 1, this is 2, this is 3. Okay, so let's look at number 1. Does it assign to each input exactly one output? Looks like it. So let's say number 1 is a function. We'll check this in a moment. Number 2, does it do that? Number 1 is not mapped to anything. I don't think that's a problem. Number 2 has 2 outcomes, so that's definitely a problem there. So we don't like that one. So this one's not a function. All right. Number 3, let's look at that one. A bit of a trick, I think.
A is 2 and 3.
They both go to A. So it's still, each of them still have one output. Yeah. So it still passes our test. Okay. So here's a trick they teach you guys, right? This is one, in case the visual thing becomes confusing. If you see these things like this, let's say at the top we have something, doesn't matter what, A, B, C, D, the bottom E, F, G, H, and there's arrows all over the place, right? So we're trying to determine based on what the arrows look like. If you see the arrows forming a shape like this, which looks like a yes, sort of, V, but I'm going to make it a yes to stretch the truth just a little bit, because Y looks like a yes, so yes, it is a function. If you see something that's an upside down V, then it's not a function. So generally, if you see this shape here in some form, then it is a function. Right, like see here, we find that shape, the V shape, so it is a function. At the top, the one that wasn't a function, we see an upside down V here. Right, so if that helps you in any way, use it. If it confuses you, don't worry about it. So just remember, look for a Y. For yes, it is a function. Yeah, sure, we can do it again. Okay, so I don't know why I wrote all this, it's unnecessary. All we need to know is if we find a shape that looks like that, then it is a function. If we find something like that, it's not a function. The example, okay. So here we see a kind of stretched out V, which is a function. As long as you see a V, it is a function. On the top, we see that upside down V, but that one is not a function. Yeah. So this actually wasn't as long an example as I thought it would be. Is that the end of it? Are there more here? That's it, okay. Okay, so we're going on to some new concepts here. So before I do, any questions about anything? All right. So now we're going to look at three different properties of functions. And we need to be able to look at a function and figure out whether it has one or two or all of these properties. And these are going to be called surjective, injective, and bijective. We need to know what these three words mean. The first one is surjective. And you know, they're always complicated a little bit more by saying it could be, you might be told surjective or you might be told the word onto. Both mean the same thing. So remember those two words. So what does a surjective function look like? Well, let's read what it tells us. When everything in the codomain is in the range, then the function is onto or surjective. So everything in the codomain is in the range. So in other words, the codomain is all the allowed outputs. So all the allowed outputs are the same as the actual outputs. Then it is surjective. So there's two examples at the bottom. Let's see if that clears things up a little bit. So look at the one that's not surjective. The one that's not surjective, clearly the codomain is at the bottom here. Those three open circles are the codomain, and those are the allowed outputs. So these are the allowed outputs. But that one is not surjective because the range are the actual outputs, and the range basically is everything being pointed to by an arrow. If an arrow points to it, then it is an output of the function, then it is a part of the range. So if there's something here that the arrow doesn't point to, that doesn't belong to the range. Right? So this middle dot here doesn't belong to the range. And by the definition of surjective, we need the codomain and the range to be the same thing. So in this case, they're clearly not the same thing. Right? So to try and simplify this in a diagram picture, if you have everything at the bottom needs to be pointed at by an arrow. If everything is pointed at by an arrow, then it's surjective. If there are some things not pointed at, then it's not surjective. Okay. I'm saying the same thing in a lot of different ways. So if you guys get confused, the video will be uploaded as well. Also, I noticed one of the videos I uploaded had no sound, which was a strange thing. So I don't know. We'll try and re-record that at some point. Anyway, this one here, I made sure the thing is not muted. Okay. So that is surjective. Let's see. We immediately move on to something else. Let me think, should I give you guys an example here? Surjective function. I have to try and think of one now. Let's see. Suppose we had function defined from, let's just make something up, from 1, 2, 3, 4 to 1, 2, 3, 4, same thing. And the function is given by f of x is equal to x. We'll call that example 1. Example 2 will be g from 1, 2, 3, make it smaller to 1, 2. Okay, we'll do the same thing again. But g of x is given by Just think 2x. Okay, but then I have to change this a little bit. Let me change that to 1, 2, 3, 4, 5, 6. Okay, here are two examples. Typical type of examples you might be given. And the question will be determine whether these functions are surjective or not. Okay, do you guys want to try that quickly before I do it? All right. Okay, guys, so if you are struggling, all you need to do here is work out what the range is and check if the range and the codomain are the same thing. If the range and the codomain are the same thing, then it's surjective. If they're not the same thing, it's not surjective. Okay, so for the first one, I think we can see the range is straightforward. Let's write it here. The range for the first one is just filtering every element from the input into the function. So if I put 1 into the function, the output is 1. If I put 2 into the function, output is 2, and so on and so on. Right? Can you guys see what I'm doing there? Right? Just filter, and then you get something. And now clearly, the range and the codomain are the same thing here. So let me just separate this, and I'll write. So here, range equals codomain. I don't know what I'm writing here. So therefore, it is surjective. So I'll just put a tick there to say it is surjective. Range equals to codomain, therefore it is surjective. Right, the second one, let's work out the range for the second one. So the range here, we just filter the inputs into a function that just doubles it basically. So the function will double each element of the, yeah, it'll just double each thing. So we'll get 2, 4, and 6. Now here's the range at the bottom in blue. The codomain is on the up on the right-hand side of the arrow. Clearly those are not the same thing. But so range not equal to codomain. Range not equal to codomain. So therefore, not surjective. So it sounds a lot more complicated in words, but when you do the thing, it's actually straightforward. Just work out the range compared to the codomain, and that's it. That's all you need. I think after the functions are done, we'll be done with this learning minute. So let me just read ahead a little bit after this one-to-one bijection, inverse image, and we're done. Okay, so we're almost there. Okay. Okay, so we learned surjective. Surjective is codomain equals to range. Now we learn injective. So injective, let's see the definition. I think this one gets a bit confusing. For each element of the codomain is the image of one element of the domain. They say at most, the image of at most one element of the domain. Then we say the function is one-to-one. Okay, so the word one-to-one helps us a lot because as long as you have a one-to-one relationship with the domain and the codomain, then it's injective. Once you see double arrows pointing downward, it's not injective. Right? So I think there was a weird analogy they gave to remember this, which is something like everything in the domain is a doctor with a COVID vaccine. Everyone at the bottom is a patient, and you need to give only one vaccine per person, some nonsense like that. And like you see here, once two doctors give one guy a vaccine, then it's not good. Then it's not injective. I think it was because the word is injective, so it sounds like injection. So that's where that comes from. I think there was a worse one where they said there's some people up here robbing a bank, and these are the tellers, and they got to stab one each or something. But that gets a bit messy, so it's not. Okay. So this one I think is more straightforward to understand because it's just one-to-one relationship. The arrow needs to just point to one guy at the bottom, and then it's injective. Okay. So are you guys still surviving? Yeah. Okay, perfect. All right, so let's try these examples here. Which of the following functions are injective? I'll give you guys a moment to think about these. You can write down things if you need to. They shouldn't be too bad, I hope. Yeah, I think we've seen these functions already, which is nice. Same stuff. Okay. Yeah, you guys got it. What's right? Yeah. Other two are fun, just two is a problem. Yeah. A little bit. Don't worry, if you talk about me, I'll act like I don't understand. It's okay. All right, guys, so let's look at these quickly. Shouldn't take too long. Number one, is this one injective? What do you guys think? Yes, it is injective, right? And we can see this clearly if we look at the domain. We compare domain to range, right?
Yeah.
Codomain. I already lost it. Yeah. Okay, so the input here is just dot 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 minus 2, minus 1, 0, 1, 2, so on. The outputs are given by, sorry, I don't know why I'm saying input, codomain. The codomain is what I've written on the top. Codomain, the range here is, as we know, minus 6, minus 3, 0, 3, 6. Okay. So let me also ask, do you guys think this one is surjective? Remember, surjective means codomain and range are the same thing. Not surjective as well. So this one is not surjective. And we are not surjective, but we've said it is injective, right? Because there's a one-to-one. Everything is mapped to exactly one other thing. -2 is mapped to 6, -1 mapped to 3, 0. There's no overlapping anywhere. So it's 1 to 1. So this is injective. Okay, so we're dealing primarily with injective. So let me ask those ones first. Number 2, does it look injective? If it's not clear, then maybe draw the diagram to see. But clearly here, let's see, 2 and 3 are mapped to the same thing. So that's like the equivalent of 2 doctors injecting 1 patient. So it's not injective. It's not injective. Is it surjective? Surjective, remember, domain equals codomain. Sorry, codomain equals range. Right? Is that the case here? Right, the range is here at the bottom. I don't think so. I don't think so, right? So it's not surjective. So you guys will see in a moment why I'm asking both questions for each one. I'm setting us up to make our lives easier later. Sorry?
Why?
Injective will be a one-to-one relationship. So because here, 2 is mapped to A and 3 is also mapped to A. They both map to the same thing.
Okay.
So that's why it's not one-to-one. Surjective compares codomain and range. Yeah, it's fine. Okay. Number 3 is injective. One-to-one relationship. Number 3. Looks like it to me. Right? Everything is mapped to something else. There's a crossing which is okay, but there's no overlap. There's no things at the top that are both pointed to the same thing at the bottom. So there's no overlap at the bottom. So this is injective. Now surjective. What do you guys think about that one? Is the codomain and range the same thing here? I think so, right? I think so. Yeah. Codomain is 1, 2, 3. Range is the same because everything here is pointed to by an arrow.
Yeah.
So this one is surjective as well. Okay, so the next section, which is supposed to take another 10 minutes, I can do it in 2 minutes because of the work we've done here already. So the next thing, we learned surjective, we learned injective. The next thing is called bijective. And bijective just means it is injective and surjective. So bijective means both of those together, right? So from this example here, we can work out which ones are bijective. Is the first one bijective? No, it's not, because it doesn't satisfy both. So because that, it's not bijective. Second one? No. Third one? Yes, that one does it. Okay. That's all we need to know about bijective. Yes. Up, sorry.
I'm saying number 2. It's not number. It's by.
Why number 2 is not bijective? Because to be bijective, it has to be surjective and injective.
No, I don't. And
Yeah, both together.
okay, I'll answer the
Yeah.
next question.
Okay. You guys all good with that?
Yeah.
Bijective. Okay. So they've given us another example here, which is the same functions, which we've just done, right? So you guys can practice again at home. Give that a try. The last thing is inverse image, and this does get slightly complicated. It's not too bad, but maybe now's not the best time to do something complicated. Do you guys, since we didn't take a break, you guys want to call it off here, or do you want to go ahead? Call it off here. Okay. You guys can read this and try it at home if you have time. If you want to, if you're in the mood, don't stress about it though. And yeah, I'll see you guys next time. Yep.